Imagine a place where a single day stretches longer than its entire year. Sounds like something out of a science fiction novel, right? Well, that's Venus for you. One sunrise to the next on our cloudy neighbor takes a mind-boggling 243 Earth days. Yet the planet zips around the sun in just 225. If that doesn't already make your head spin, hold on tight because we're just getting started. In the next few minutes, we're going to blast past our cozy little corner of the cosmos and dive headfirst into a universe so strange and magnificent, it'll make your everyday worries feel utterly trivial. We're talking planets where molten glass rains from the sky, stars that are colder than your freezer, and black holes so massive they could swallow entire solar systems for breakfast. By the time we land this cosmic journey, your understanding of the universe will be bigger, weirder, and surprisingly a lot more personal. You'll see how interconnected everything truly is, and just how much more there is to discover. Cosmic neighbors that break the rules. Let's kick things off right here in our cosmic backyard. You probably think Mars is the solar system's resident oddball, don't you? With its iconic red dust, planet-engulfing dust storms, and those undeniably picturesque chocolate bar sunsets, it definitely has its quirks. But honestly, Venus is the real enigma, the true rebel of the inner solar system. Its incredibly thick atmosphere, a suffocating blanket of carbon dioxide, doesn't just trap heat. It cranks the surface pressure to an astonishing 92 times what you're feeling right now. To put that in perspective, that's the same crushing pressure you'd experience if you were half a mile deep under Earth's oceans. And the temperatures? They consistently hover around a searing 465 degrees Celsius, hot enough to melt lead, zinc, and even some types of rock. It's a truly hellish landscape, a perpetual oven. Yet here's where it gets truly wild. Venture about 50 kilometers above that infernal ground, and the air miraculously cools to a rather balmy 30 degrees Celsius, where the atmospheric pressure eerily matches Earth's sea level conditions. Scientists have dubbed this perplexing region the temperate zone, and it's not just a theoretical curiosity. Some visionary researchers have seriously proposed the concept of cloud cities for Venus, giant, floating habitats kept aloft by breathable air that, due to the atmospheric composition and temperature differences, would behave like a lifting gas. Imagine sipping your morning coffee, looking out your window as swirling sulfuric acid clouds drift serenely past. It's an insane, yet captivating vision of future colonization. Speaking of acid rain and extreme environments, let's swing by Jupiter's moon Io. This place is essentially a giant, perpetually active pizza floating in space, constantly being retopped with fresh volcanic spew. The surface is a riot of yellows, oranges, and reds, all thanks to sulfur in its various forms. And we're not talking about a few sleepy volcanoes here. Io boasts over 400 active volcanoes, constantly pumping out plumes that can reach incredible heights, sometimes soaring 500 kilometers above the surface. What drives all this volcanic fury? It's a brutal tug-of-war, a cosmic wrestling match between Jupiter's immense gravity and the gravitational pulls of its other large moons. This relentless kneading and stretching of Io's interior generates so much internal friction and heat that the rock melts, creating magma without needing any sunlight whatsoever. It's a truly unique form of geological activity. If you were brave or foolish enough to stand on Io's surface, the intense radiation from Jupiter's magnetic field would unfortunately kill you in mere minutes. But before that, you'd experience something utterly bizarre. The ground beneath your feet would rise and fall by an astonishing 100 meters during each orbit. That's like watching the Empire State Building spontaneously lie down and then stand back up again, all happening every 42 hours. Talk about an unstable foundation. And then there's Saturn, the undisputed jewel of our solar system with its majestic rings. But here's a lesser-known fact that will make you scratch your head. Saturn is less dense than water. Seriously, if you could find a cosmic bathtub large enough, this ring giant would float and bob around like a cork. It's mostly hydrogen and helium, making it incredibly lightweight for its gargantuan size. Data from the Cassini probe revealed that winds near Saturn's equator can whip up to an astonishing 1,800 kilometers per hour. That's 4 times the speed of a Category 5 hurricane here on Earth. Imagine trying to stand your ground in that. Yet high above these superstorms, one of Saturn's moons, Titan, presents a surprisingly Earth-like landscape. It hosts rivers, lakes, and even seasonal rain, but with a crucial difference. The liquid isn't water, it's liquid methane. The James Webb Space Telescope, or JWST, recently caught an incredible glimpse of clouds forming over Titan's North Pole for the very first time. This observation was a huge deal, confirming that Titan's unique hydric cycle, albeit based on methane, is alive and well, complete with evaporation, cloud formation, and precipitation, all occurring at a frigid minus 179 degrees Celsius. So if you're planning a visit, make sure you pack a really good jacket, perhaps one made of some futuristic super insulating material. Exoplanets, the ultimate weirdness amplifier. Cast your mind back to 1995. What did we know about planetary systems beyond our own? Practically nothing. We knew of one planetary system, the one we call home. Fast forward to today, and the landscape has completely transformed. The tally of confirmed exoplanets, worlds orbiting stars other than our sun, has just soared past 6,000. And get this, there are another 10,000 candidates patiently waiting in the queue for confirmation. This isn't just a steady trickle of discoveries. Astronomers are unearthing new worlds at a rate faster than you can binge watch an entire season of your favorite show on Netflix. It's an explosion of knowledge, revealing a universe far more diverse and populated than we ever dared to imagine. These newfound worlds are often unlike anything we've ever seen in our own solar system. We found Jupiter-sized giants, for example, that orbit so incredibly close to their stars that they make Mercury's journey around our sun look like a leisurely stroll. These hot Jupiters challenge our understanding of planetary formation. Conversely, rocky planets, similar in composition to Earth, appear to be far more common across the galaxy than gas giants. This suggests that Earth-like worlds, while not necessarily habitable, might be incredibly abundant. Let's talk about some of these extreme alien worlds. Take WASP 76b, for instance. On this hellish planet, temperatures on the day side skyrocket above 2,400 degrees Celsius. This isn't just hot, it's hot enough to vaporize iron. Imagine that. Iron evaporates on the day side, forming clouds of gaseous metal that then drift over to the slightly cooler night side. There, the metallic vapor condenses and falls as, you guessed it, molten iron rain. Scientists quite literally call it iron rain. It's an environment that would make even the toughest science fiction scenarios seem tame. Or consider K2-18b, a fascinating sub-Neptune exoplanet. Its atmosphere contains significant amounts of water vapor, and researchers are debating whether it might even host vast swaths of supercritical fluid. What makes K2-18b particularly intriguing is that it orbits within its star's habitable zone, the region where conditions could be just right for liquid water to exist on the surface. So, the big question is it a mini Neptune swaddled in a thick, steamy envelope of gas and water? Or is it a rocky super-Earth, perhaps concealing an ocean 10 times deeper than any ocean found on our home planet? The implications for potential habitability are profound, making it a prime target for future study. Then there's Bebop 3b, a circumbinary planet that pulls off an incredible celestial dance, around not one, but two suns. Talk about some serious tattooing vibes, right? This system is a powerful testament that planets can, indeed, form and survive, thriving even, within the chaotic gravitational embrace of a double star system, a scenario that theorists once considered nearly impossible. If you were lucky enough to live on Bebop 3b, you wouldn't just witness two breathtaking sunsets, you'd also be treated to two spectacular sunrises every day. And as for the seasons, well, every shift in the weather patterns would probably feel less like an almanac entry and more like a complex mathematical problem as the planet navigates the combined gravitational influences of its dual stellar parents. Recent breakthroughs by the James Webb Space Telescope have further deepened our understanding of these distant worlds. JWST has been capturing spectra of exoplanets like TRAPPIST-1e, providing crucial data for characterizing their atmospheres and searching for potential biosignatures. And it's not just about fully formed planets. Astronomers have also observed WASP-2b, a young planet actively clearing a gap in its protoplanetary disk, offering us a rare direct glimpse into the very process of planet formation as it happens. Another exciting discovery is GJ3998d, a super-Earth nestled comfortably within the habitable zone of a nearby red dwarf star. This makes it an incredibly compelling candidate for in-depth atmospheric study, a true frontier in the search for life beyond Earth. We're also studying planets like HD 20794d, a super-Earth that takes an eccentric path, periodically swinging in and out of its star's habitable zone. These dynamic worlds are like natural laboratories, providing unique insights into the conditions that might support life under varying environmental pressures. Future instruments, such as the Extremely Large Telescope, ELT, are being designed to probe the atmospheric composition and surface conditions of these worlds with unprecedented detail. The golden age of exoplanet discovery is truly just beginning, and with every new find, the universe feels a little less lonely and a lot more astonishing. Exoplanets, the ultimate weirdness amplifier. Cast your mind back to 1995. What did we know about planetary systems beyond our own? Practically nothing. We knew of one planetary system, the one we call home. Fast forward to today, and the landscape has completely transformed. The tally of confirmed exoplanets, worlds orbiting stars other than our sun, has just soared past 6,000. And get this, there are another 10,000 candidates patiently waiting in the queue for confirmation. This isn't just a steady trickle of discoveries. Astronomers are unearthing new worlds at a rate faster than you can binge watch an entire season of your favorite show on Netflix. It's an explosion of knowledge, revealing a universe far more diverse and populated than we ever dared to imagine. These newfound worlds are often unlike anything we've ever seen in our own solar system. We found Jupiter-sized giants, for example, that orbit so incredibly close to their stars that they make Mercury's journey around our sun look like a leisurely stroll. These hot Jupiters challenge our understanding of planetary formation. Conversely, rocky planets, similar in composition to Earth, appear to be far more common across the galaxy than gas giants. This suggests that Earth-like worlds, while not necessarily habitable, might be incredibly abundant. Let's talk about some of these extreme alien worlds. Take WASP-76b, for instance. On this hellish planet, temperatures on the day side skyrocket above 2,400 degrees Celsius. This isn't just hot, it's hot enough to vaporize iron. Imagine that. Iron evaporates on the day side, forming clouds of gaseous metal that then drift over to the slightly cooler night side. There, the metallic vapor condenses and falls as, you guessed it, molten iron rain. Scientists quite literally call it iron rain. It's an environment that would make even the toughest science fiction scenarios seem tame. Or consider K218b, a fascinating sub-Neptune exoplanet. Its atmosphere contains significant amounts of water vapor, and researchers are debating whether it might even host vast swaths of supercritical fluid. What makes K218b particularly intriguing is that it orbits within its star's habitable zone, the region where conditions could be just right for liquid water to exist on the surface. So, the big question is it a mini Neptune swaddled in a thick, steamy envelope of gas and water? Or is it a rocky super-Earth, perhaps concealing an ocean 10 times deeper than any ocean found on our home planet? The implications for potential habitability are profound, making it a prime target for future study. Then there's Bebop 3b, a circumbinary planet that pulls off an incredible celestial dance, around not one, but two suns. Talk about some serious tattooing vibes, right? This system is a powerful testament that planets can, indeed, form and survive, thriving even, within the chaotic gravitational embrace of a double-star system, a scenario that theorists once considered nearly impossible. If you were lucky enough to live on Bebop 3b, you wouldn't just witness two breathtaking sunsets, you'd also be treated to two spectacular sunrises every day. And as for the seasons, well, every shift in the weather patterns would probably feel less like an almanac entry and more like a complex mathematical problem as the planet navigates the combined gravitational influences of its dual stellar parents. Recent breakthroughs by the James Webb Space Telescope have further deepened our understanding of these distant worlds. JWST has been capturing spectra of exoplanets like TRAPPIST-1e, providing crucial data for characterizing their atmospheres and searching for potential biosignatures. And it's not just about fully formed planets. Astronomers have also observed WASP-2b, a young planet actively clearing a gap in its protoplanetary disk, offering us a rare direct glimpse into the very process of planet formation as it happens. Another exciting discovery is GJ3998d, a super-Earth nestled comfortably within the habitable zone of a nearby red dwarf star. This makes it an incredibly compelling candidate for in-depth atmospheric study, a true frontier in the search for life beyond Earth. We're also studying planets like HD 20794d, a super-Earth that takes an eccentric path, periodically swinging in and out of its star's habitable zone. These dynamic worlds are like natural laboratories, providing unique insights into the conditions that might support life under varying environmental pressures. Future instruments, such as the Extremely Large Telescope, ELT, are being designed to probe the atmospheric composition and surface conditions of these worlds with unprecedented detail. The golden age of exoplanet discovery is truly just beginning, and with every new find, the universe feels a little less lonely and a lot more astonishing. Galactic jets that outsize galaxies. When you picture galaxies, you probably envision beautiful, swirling spirals or majestic elliptical clouds of stars. And while many are, there's a whole other, far more violent side to galactic existence. Many galaxies are actively firing colossal particle cannons into intergalactic space. These aren't just little squirts. We're talking about jets of plasma that dwarf the galaxies themselves. The current record holder for such a phenomenon is an enormous galactic jet emanating from a galaxy nicknamed Perseus. This incredible structure flaunts a jaw-dropping length of 23 million light-years. To put that into perspective, that's longer than 200 Milky Way galaxies laid end to end. Think about that for a second. These aren't just random emissions. They are incredibly powerful, highly collimated beams of matter. These jets are powered by the supermassive black holes lurking at the centers of active galaxies. As matter spirals into the black hole's accretion disk, it forms a superheated, highly magnetized plasma. Magnetic fields, acting like cosmic funnels, channel some of this matter away from the black hole's event horizon, accelerating it to near light speed in two opposite directions, forming these spectacular twin beams. Along their incredible journeys, these galactic jets don't just travel, they actively shape the universe. They heat the diffuse intergalactic gas, preventing it from cooling and forming new stars, and thereby playing a crucial role in regulating star formation within galaxy clusters. They also sculpt the cosmic web, the vast filamentary structure of matter that permeates the universe, and can even influence how galaxies themselves form and evolve. Essentially, these jets act like cosmic blowtorches, carving out vast bubbles and influencing the distribution of matter and energy on the largest scales imaginable. They challenge our current cosmological models because they remain coherent and powerful over such immense distances and timescales, actively magnetizing intergalactic space and distributing energy across the universe. They are a stark reminder of the incredible power and dynamism hidden within the hearts of galaxies. The universe is expanding, and it's accelerating. Back in the 1920s, the brilliant astronomer Edwin Hubble delivered a bombshell. He showed us that galaxies aren't static, they're actively flying apart from each other, indicating that the universe itself is expanding. For decades, the prevailing wisdom was that this expansion, while ongoing, should be gradually slowing down due to the gravitational pull of all the matter within the cosmos. It made intuitive sense, like a ball thrown upwards eventually slowing before it falls back down. But then, in 1998, two independent teams of astronomers made an astonishing and completely unexpected discovery. The universe's expansion isn't slowing down at all. It's actually speeding up. This groundbreaking revelation earned them a Nobel Prize and fundamentally changed our understanding of the cosmos. The culprit behind this cosmic acceleration? Something mysterious and elusive we call dark energy. This enigmatic force makes up an astounding 68% of everything in the universe, yet we still have no idea what it actually is. It's one of the biggest unsolved mysteries in science, a cosmic ghost pushing everything apart. To help visualize this mind-bending concept, picture the cosmos like a loaf of raisin bread baking in an oven, only in fast forward. As the dough rises and expands, every raisin sees every other raisin moving away from it. It's the same principle in the universe. Eventually, galaxies beyond our local group will become so incredibly distant and receding so rapidly that their light will no longer be able to reach us. From Earth, future astronomers will look out into those distant reaches and see only an impenetrable darkness. This sobering thought highlights a profound point. We are currently living in a unique golden age of cosmology. We can still observe and study the vast, distant universe, but that window won't last forever. So enjoy the view while we still have one, because the cosmic tapestry we see today is a fleeting spectacle.
Interstellar visitors that zoom through our backyard. Our solar system, for all its vastness, isn't an isolated bubble. It's part of a bustling galactic neighborhood, and every now and then, a visitor from another star system zips through our cosmic backyard. These are interstellar objects, and their appearance tells us something profound about the universe. In 2017, the astronomical world was abuzz with the discovery of Oumuamua. This elongated, cigar-shaped object streaked past the sun, tumbling end over end every 8 hours. Its bizarre shape and trajectory immediately signaled that it wasn't from our solar system. Then, in 2019, comet Borisov made its grand entrance, another confirmed interstellar guest. What made Borisov particularly interesting was its composition. It was found to be twice as rich in carbon monoxide compared to comets born within our own solar system, offering a tantalizing glimpse into the chemistry of another stellar nursery. These weren't just isolated incidents. In 2025, astronomers confirmed the detection of the third interstellar object ever observed. These cosmic vagabonds, these fragments of distant worlds, are incredibly significant. They tell us that planetary systems routinely eject material, whether it's comets, asteroids, or even larger debris, seeding the galaxy with fragments of their parent worlds. It's like cosmic litter, but in the best possible way. Think about it. Every atom in your body was forged inside the heart of a star. But some of those atoms, those fundamental building blocks of you, may have taken an incredibly long and winding detour through another planetary system, perhaps orbiting a different star for eons, before eventually finding their way here to become part of you. Does that make you feel a little more cosmopolitan, a little more connected to the vast, swirling expanse of the galaxy? It should. These interstellar travelers are tangible proof of the dynamic and interconnected nature of our cosmic neighborhood. Gravitational waves, the new cosmic rumble. For most of history, our understanding of the universe has relied almost entirely on light, from radio waves to gamma rays. But there's another way to see the cosmos, a way to listen to its deepest rumbles: gravitational waves. These aren't electromagnetic waves like light. They're ripples in the very fabric of space-time itself, predicted by Albert Einstein over a century ago. It wasn't until 2015 that humanity finally heard them. The Laser Interferometer Gravitational Wave Observatory, or LIGO, made headlines worldwide when it detected the faint, yet unmistakable ripples from two black holes merging billions of light years away. This monumental discovery confirmed a key prediction of Einstein's theory of general relativity and opened up an entirely new window into the universe. It was like suddenly being able to hear a symphony that had been playing silently for eons. But that was just the beginning. Now the upcoming Laser Interferometer Space Antenna, or LISA mission, is poised to take this gravitational wave astronomy to the next level. Instead of ground-based detectors, LISA will deploy 3 spacecraft in a triangular formation, flying millions of kilometers apart in space, using lasers to precisely measure tiny distortions in space-time. This ambitious mission aims to detect gravitational waves from even more colossal events, specifically the mergers of supermassive black holes, those gargantuan behemoths lurking at the centers of galaxies billions of light years away. With LISA, astronomers won't just be mapping the universe with light, they'll be mapping it with gravity. This means we'll be able to peer into the dark era of the universe, the period before the first stars and galaxies even formed, when the cosmos was opaque to light. It's a paradigm shift, like switching from relying solely on visible sight to suddenly gaining the ability of echolocation. Imagine being able to see in the dark, to sense the most powerful and distant events in the universe through the subtle vibrations they leave in space-time. This new cosmic rumble promises to unlock secrets about the universe's earliest moments and the most extreme objects within it.
Jupiter's auroras outshine Earth's entire power grid. You've probably seen stunning images of Earth's auroras, the northern and southern lights, beautiful, ethereal curtains of color dancing across our polar skies. Now, imagine something hundreds of times brighter, more energetic, and far more violent. That's Jupiter's auroras for you. The James Webb Space Telescope recently captured breathtaking images of Jupiter's northern and southern lights, blazing with an intensity hundreds of times greater than anything we've ever witnessed on Earth. What makes Jupiter's aurora so incredibly powerful? It's a combination of its immense magnetic field, the strongest of any planet in our solar system, and a constant supply of charged particles, primarily from its volcanically active moon Io. These charged particles get caught in Jupiter's colossal magnetic field, are accelerated to incredible speeds, and then slam into the planet's upper atmosphere near its magnetic poles. This violent collision excites atmospheric gases, causing them to glow. But Jupiter takes it a step further, generating X-ray bursts so powerful they can briefly outshine the sun in high-energy light. It's an incredible display of raw cosmic power. If you could somehow stand inside one of those auroral ovals, the sky would flicker with curtains of crimson and ultraviolet light, a truly spectacular and terrifying display. But it wouldn't be a pleasant experience. The radiation dose from those charged particles would be so intense, it would kill you faster than a microwave oven on steroids. It's a beautiful, deadly dance of light and energy, revealing the incredible complexity of Jupiter's magnetosphere and its interactions with its moons. It's a stark reminder that beauty in the cosmos often comes hand in hand with extreme, life-ending conditions. Section 10. Titan's clouds and methane monsoons. We talked about Saturn's moon Titan earlier, but it deserves a deeper dive. This moon is arguably one of the most Earth-like bodies in our solar system, albeit with a chilling twist. Titan's gravity is remarkably low, only about 1/7 of Earth's. This means that if you were equipped with some homemade wings and, crucially, a heated pressure suit to survive the frigid temperatures and maintain breathable air, you could theoretically flap your arms and soar through its thick atmosphere like a bird. The thought alone is exhilarating. Titan's atmosphere is dense, rich in nitrogen, and features a unique hydrologic cycle. But it's not based on water. Instead, it's all about methane and ethane. Imagine raindrops, not of water, but of liquid methane. These methane raindrops are about twice the size of terrestrial raindrops. Yet, because of Titan's low gravity and dense atmosphere, they fall incredibly slowly, in near silence. It would be a truly surreal experience, a gentle, ethereal rain falling softly onto a landscape of icy mountains and vast, liquid hydrocarbon lakes. The James Webb Space Telescope, with its keen infrared eyes, recently provided us with a stunning new insight into Titan's weather patterns. It caught fascinating glimpses of convective clouds bubbling up in Titan's northern hemisphere. This was a significant observation, signaling the beginning of summer monsoons on this distant moon. These aren't just isolated events. Titan's lakes and seas, vast bodies of liquid methane and ethane, can remain calm and still for centuries. But when these methane monsoons arrive, they can trigger dramatic changes, with waves suddenly building across the liquid surfaces, carving out coastlines that look like alien versions of Malibu's famous beaches. The continuous replenishment of these lakes by methane and ethane rain ensures that Titan's unique cryogenic hydrologic cycle remains active and dynamic. It's a truly alien world, yet one that mirrors Earth in its fundamental geological and meteorological processes, offering a tantalizing glimpse of what life might look like under vastly different chemical conditions. Mid-roll CTA. If your grain isn't dripping out your ears yet, honestly, that's pretty impressive. You're a true cosmic connoisseur. If you've enjoyed this journey through the universe's most mind-bending facts, do us a huge favor. Smash that like button. It tells the algorithm that this content is worth sharing, helping another curious human discover the wonders we've explored today. And while you're at it, why not subscribe? Because in the next half of our cosmic adventure, we're going to dive even deeper, visiting a black hole smaller than a city, yet heavier than our sun, and we'll unravel the truly wild concept of why time literally stops at its doorstep. Don't miss it. The black hole event horizon is a one-way door. Black holes are perhaps the most enigmatic and terrifying objects in the universe. And at the heart of their mystery lies the event horizon, the ultimate point of no return. Cross this invisible boundary, and even light, the fastest thing in the cosmos, can't turn around and escape its gravitational grasp. It's a true one-way door to oblivion. From an outside observer's perspective, watching an object fall into a black hole is a bizarre spectacle. Due to extreme time dilation, you'd never actually see the object fully cross the event horizon. Instead, its image would appear to slow down, becoming redder and dimmer until it seems to freeze, forever suspended at the very edge of the black hole, a ghostly silhouette against the cosmic backdrop. It's a chilling visual effect of general relativity. However, for the unfortunate infalling astronaut, the experience is radically different. The crossing of the event horizon would happen in an instant, a mere heartbeat. But what comes next is truly horrific. tidal forces. These are the differential gravitational pulls across an object. As the astronaut approaches the singularity, the gravitational pull on their feet would be vastly stronger than on their head, stretching their body lengthwise while compressing it widthwise. This process, known colloquially as spaghettification, would tear them apart atom by atom, turning them into a long, thin strand of matter before they even reach the singularity itself. It's a gruesome yet fascinating consequence of extreme gravity. Recently, the James Webb Space Telescope offered a subtle yet powerful clue about a hidden black hole. JWST spotted highly ionized neon gas swirling within the spiral galaxy Messier 83. This gas was glowing at temperatures far hotter than physics would allow under normal circumstances. The only plausible explanation? A supermassive black hole, quietly lurking at the galaxy's core, was actively shredding stars and other celestial material, heating the surrounding gas to extreme temperatures. This indirect detection method reveals just how many of these cosmic monsters might be hiding in plain sight, silently dictating the dynamics of their host galaxies. It's a testament to the fact that the universe still holds countless secrets, even in our closest galactic neighbors. A city-sized star that spins 715 times per second. When we think of stars, we rarely think of speed, beyond their galactic orbits. But pulsars are a different breed entirely. These are rapidly spinning neutron stars, the ultra-dense remnants of massive stars that have gone supernova. And PSR J1748-2446 AD holds the title for the fastest spinning pulsar known to humanity. This incredible object, roughly the size of a city, completes an astonishing 716 rotations every single second. To put that in perspective, a point on its equator is traveling at nearly a quarter of the speed of light. If you could somehow stand on its surface, ignoring the unfathomable gravity and the billion Gauss magnetic field that would instantly tear you apart, you would witness the universe blur into incomprehensible streaks. The very fabric of spacetime around it would be distorted by its rapid rotation. Pulsars are often described as cosmic lighthouses. As they spin, their powerful magnetic fields funnel beams of radiation from their magnetic poles. If one of these beams sweeps across Earth, we detect it as a regular pulse. PSR J1748-2446 AD, Lighthouse beam sweeps past our planet every 1.4 milliseconds. With a precision so incredible, it's more reliable than the most accurate atomic clocks humans have ever built. This extreme regularity isn't just a curiosity. It's a powerful scientific tool. Some pulsars keep time so exquisitely well that astronomers use them as cosmic reference points to detect background gravitational waves passing through the Milky Way. These subtle ripples in space-time, too faint for current ground-based detectors, can be inferred by minute changes in the timing of pulsar pulses. It's a testament to the universe's own intricate clockwork, providing us with a unique way to study cosmic phenomena.
The cosmic web looks like a neuron forest. If you could somehow zoom out far enough beyond individual galaxies and clusters, the universe would reveal its grandest structure, the cosmic web. This isn't just a random scattering of galaxies. It's an intricate, interconnected network that bears a striking resemblance to a colossal brain, or perhaps a vast neuron forest. Modern cosmological simulations and extensive galaxy surveys have unveiled this incredible architecture. Matter in the universe isn't uniformly distributed. Instead, it arranges itself into colossal filaments, massive nodes, and vast empty voids. These filaments are like cosmic highways, stretching for hundreds of millions of light years, along which galaxies are strung like pearls on a necklace. Where these filaments intersect, they form dense nodes, which are typically home to massive galaxy clusters.
Conversely, between these filaments and node lie immense voids, regions of space that are hundreds of times emptier than the cosmic average. These voids collectively occupy an astonishing 80% of the universe's volume. They are truly the greatest empty spaces known to science. But these voids aren't entirely passive. We're discovering that galactic jets, those powerful particle cannons we discussed earlier, play a crucial role here. They feed immense amounts of energy into these voids, actively heating and magnetizing the sparse intergalactic gas, effectively puffing them up even further. In essence, supermassive black holes, through their powerful jets, are inflating the universe's own bubble wrap, shaping the very large-scale structure of the cosmos. This intricate interplay between dark matter, which provides the gravitational scaffolding for the web, ordinary matter, and active galactic nuclei, creates a universe that is both beautifully structured and dynamically evolving, far more complex than a simple uniform distribution. Why 1,000,000 Earths fit inside the sun? Our sun, that familiar, life-giving star in our sky, is far more immense and powerful than we often realize. It accounts for a staggering 99.86% of the entire solar system's mass. To put its size into perspective, you could comfortably fit approximately 1,000,000 Earths inside it. Imagine that, 1,000,000 of our home planets all swallowed by this single fiery sphere. At its core, the sun is a colossal nuclear fusion reactor. Every single second, it fuses an astonishing 600 million tons of hydrogen into helium. This process, driven by immense temperatures and pressures, releases an unfathomable amount of energy, equivalent to 4 × 10 to the 26 watts. To give you an idea of that power, if we could somehow harness all that energy, a mere single tick of the solar clock would be enough to power our entire global civilization for 500,000 years. It's an almost incomprehensible output. The journey of that energy, however, is not a quick one. The light produced in the sun's incredibly dense core doesn't just zoom straight out. Instead, it embarks on an epic, tortuous journey, bouncing and scattering off countless atoms within the sun's interior. This process takes an astonishingly long time, around 100,000 years, before that light finally escapes the surface and begins its relatively swift 8-minute trip to Earth. So when you feel the warmth of the sunlight on your face today, remember this: the photons responsible for that warmth were generated in the sun's core when humans were still living in caves, long before recorded history. It's a profound connection to the ancient past, delivered to us by a star that continues to burn with unimaginable power. The most powerful explosion since the Big Bang. The universe, for all its serene beauty, is also home to moments of truly cataclysmic violence. And few phenomena showcase this better than gamma-ray bursts, or GRBs. These are the most powerful explosions in the cosmos, capable of releasing more energy in a mere 10 seconds than our sun will emit over its entire 10 billion year lifespan. It's an almost unimaginable burst of pure energy. The record holder for these cosmic fireworks is GRB 2210009A, an event that stunned astronomers when it flooded detectors last October. This incredible burst was so potent that it actually ionized Earth's upper atmosphere and briefly disrupted radio communications. Astronomers, in a moment of inspired understatement, nicknamed it the Boat, the brightest of all time. The progenitor star, the massive star that collapsed to create the spectacle, exploded a staggering 2.4 billion light-years away. Yet, despite that immense distance, its radiation briefly outshone the full moon in our sky. GRBs are thought to originate from 2 primary scenarios: either the collapse of extremely massive stars, hypernovae, that form black holes, or the merger of 2 neutron stars. Both events produce jets of highly energetic particles that, if pointed directly at Earth, can have devastating consequences. If a gamma-ray burst were to go off within a few thousand light-years of Earth, the resulting flood of high-energy radiation could strip away our ozone layer, trigger mass extinctions, and fundamentally alter our planet's climate. It's a terrifying thought. But thankfully, such events are incredibly rare, and there are no known candidates close enough to pose an immediate threat. So for now, we're safe. Probably. It's a powerful reminder of the raw, untamed forces that play in the universe, and how lucky we are to be living in a relatively quiet corner of it. Conclusion. Bringing it home. We started this incredible journey on a planet where a single day somehow manages to outlast an entire year, a truly bizarre cosmic anomaly. And we're concluding it with explosions so powerful they dwarf everything our familiar sun will ever achieve. Between those two mind-bending extremes, we've encountered worlds bathed in iron rain, witnessed city-sized stars spinning at impossible speeds, and discovered black holes that aren't just cosmic vacuum cleaners, but active sculptures of the vast cosmic web. The universe, in its infinite wisdom, really doesn't care if these facts bend your mind into a pretzel. It simply keeps expanding, accelerating, and inventing new, spectacular ways to amaze us, to challenge our perceptions, and to ignite our curiosity. If you learned something today that made you pause, that sparked a flicker of wonder, then please pass that wonder along. Share this video with someone else who loves a good cosmic mystery. Drop your favorite mind-blowing fact in the comments below. And most importantly, don't forget to subscribe so you don't miss our next adventure. The cosmos is under no obligation to make sense to us, that much is clear. But that won't stop us, humanity, the curious, the explorers, from trying to unravel its magnificent secrets, one unbelievable fact at a time.